Degeneracy in transportation problem. We know that for an initial basic feasible solution in a general transportation problem, the number of occupied cells must be m plus n minus 1, where m is the number of supply and n is the number of demand. If for a given transportation problem, the number of occupied cells is less than m plus n minus 1, then the solution is known as degenerate solution. That is, if number of allocations are not equal to m plus n minus 1, then the solution is known as degenerate solution. In such a position, the current solution cannot be improved because it is not possible to draw a closed path for every occupied cells. Also, for number of occupied cells less than m plus n minus 1, the values of ai and bj are equals to 1 to m and j running from 1 to n, which are used in the test of optimality, cannot be computed. For the test of optimality, we use model method we see in the last lecture. So, degeneracy in a transportation problem occurs in two stages. First, at initial stage, and second, at intermediate stage. How to resolve the degeneracy in transportation problem? For this, we see the example. So, this is the example. Obtain the optimal solution of the following transportation problem using MODI method. This is transportation problem. So here number of allocations are 1, 2, 3 and 4. So number of allocations are 4, which is not equals to m plus n minus 1. M is 3 plus n is also 3 minus 1, that is 5. So m plus n minus 1 is 5. Therefore, number of allocations not equal to m plus n minus 1. So the transportation problem is degenerate. To resolve the degeneracy by the addition of small quantity epsilon to suitable unoccupied cell. There are 1, 2, 3, 4 and 5 unoccupied cells, from which we add a small quantity epsilon in order to resolve the degeneracy. We can resolve the degeneracy of the problem by adding epsilon to any one of the unoccupied cell, or mostly we take the least cost unoccupied cell. So from these unoccupied cells, that is 1, 2, 2, 2, 3, 1 and 3, 3. Least cost is, so first is 8, 7, 8, 11, 5. So least cost is 5. So we allocate epsilon to least cost independent unoccupied cells 3, 3. So we allocate epsilon to unoccupied cell 3, 3. So the above table becomes, so this table becomes allocations are 60 as it is, 50, 20, 80 and this is epsilon. So here number of allocations are 5, which is equals to m plus n minus 1. So this is non-degenerate problem. So here requirement becomes 60 plus 20 plus epsilon, that is 80 plus epsilon. So x13 equals to 60 x21 equals to 50, x23 equals to 20, x32 equals to 80, and x33 equals to epsilon, which is nearly equal to 0. So total transportation cost equal to 60 into 3 plus 50 into 3 plus 20 into 9 plus 80 into 3 plus epsilon into 5. That is, this is equals to rupees 750. Now addition of epsilon does not affect the transportation cost of the transportation problem. Now we have to test the solution for optimality by Modi method. That is for occupied cells. Use UI plus Vj equals to Cij. Take any UI equals to 0. So here U1, U2, U3, V1, V2, V3. So any one of this UI we take 0. Probably we take maximum number of allocations. Here we take U3 equals to 0. Here there are 2 allocations in this row. Here U3 equals to 0. U1 plus V3 equals to 3. U2 plus V1 equals to 3. U2 plus V3 equals to 9. U3 plus V2 equals to 3. U3 plus V3 equals to 5. I explained this Modi method in the last video. So I take directly here. So here U3 0 implies V3 equals to 5. Here V2 equals to 3. So here we put V3 equals to 5. So we get U1 equals to minus 2. Here V3 equals to 5. So we get U2 equals to 4. And here V1 equals to minus 1. That is U1 minus 2, U2 4, U3 0. And V1 equals to minus 1, V2 equals to 3, and V3 equals to 5. Now for unoccupied cells, we use Dij equals to Cij minus Ui plus Vj. There are 4 unoccupied cells: 1 1, 1 2, 2 2, and 3 1. So C11 minus U1 plus V1. C11 is 8 minus U1 is minus 2 minus 1. So here 11. C1 2 is 7 minus U1 is minus 2 plus 3. So here is 6. C22 is 8 minus U2 is 4 plus V2 is 3. So here 1. Or D31, C31 is 11 minus U3 plus V1 minus 1. That is equals to 12. Now entering all values of UI, Vj and Dij in the table. So this is the table with all the values of UI, Vj and Dij. Here all Dij greater than 0. So the solution is optimal and unique. Therefore, total transportation cost equals to rupees 750. That is, addition of epsilon does not affect the value of transportation cost.